and she had an idea for a new book whose exploits already affect the future of most of the world's population. She wanted to write of the doctors and scientists who work to combat the diseases which infect countless millions. She would tell their story, themselves take to achieve their ultimate goal, the eradication of disease. A year before she finally returned home for good, and the others in this series. To start, June Goodfield wanted to find out what happens when doctors come up against a new and unknown disease. What do they do? How do they find protection for those at risk? Where do they start? There was a mysterious disease in a tribe of cannibals on the other side of the world. What doctors found when they took the first routine step to find its cause electrified the entire world of medical science.
No matter who they are, people have always beseeched their gods for deliverance from the pain and suffering of disease. And in the early 1950s, there was a tribe in the remote eastern highlands of Papua, New Guinea, that had reason to pray.
They were still emerging from their Stone Age. There were 14,000 of them, and they rarely traveled far from their land. And when they did, it was usually to wage war with bows and arrows and poisoned darts. They were called the Foray tribe. More than 30 years ago, in the early 50s, rumors of a plague here in the Eastern Highlands reached the Australians, who were in charge of Papua at that time. A young patrolman was sent from Port Moresby, 250 miles away, to find out what was happening. It took him several weeks to make his way into the interior, climbing higher into the mountains all the time. He had heard that the Foray people called the disease Kuru, a word which meant the trembling sickness. There had been many deaths. It was rough country and tough going. At last he arrived on a plateau 1 mile above sea level near the largest of the Foray villages. As he approached, he could sense that something was dreadfully wrong. When he got closer, he was appalled by what he saw. This was Kuru. It was coincidence that brought a remarkable character to Papua. He was a children's doctor, a pediatrician, originally from New York, and his name was Carlton Gajuzek. He'd heard the rumors about Kuru. There was only one way to get there, and Gajuzek hacked his way into the Eastern Highlands on foot, passing through many different tribal territories to reach the remoteness of Foray country.
Carlton Gajusek has been most helpful with the details of his part in the story, but these days he adamantly refuses to be filmed for television. He has some sort of thing about it. This first snapshot of him was taken when he reached the Foray country in 1957. He learned to speak the Foray language and was finding out what the villagers could tell him about the disease. He had never seen anything like Kuru in his life before. When a doctor meets this kind of puzzle, there's a scientific way of going about things. The first essential is to discover the actual cause of the disease, for only then can you start looking for an effective remedy. Somewhere in that wild country down there was the clue to the cause of Kuru. Carlton Gadusek set up headquarters and opened a clinic.
This rare film of him was taken by an Australian cameraman in 1957. Gadusek had been in the Eastern Highlands for 6 months, and the Australian film team had been sent to make a record of the tragedy. By now, Gadusek knew that whatever the cause of the disease, it was affecting the centers in the brain which controlled muscular coordination. Standard neurological tests showed that not all reflexes were affected by Kuru in the same way. If it were an infective disease, it was a most unusual one. There were none of the symptoms a doctor would expect to find. Temperatures, raised blood counts, and the like, and antibiotics were useless. He tried most of the other drugs he had with him, but they didn't help either. From the first minor symptoms, the course of Kuru was relentless and fatal. Towards the end, even the ability to swallow disappeared, and some of the victims were literally starving.
Gadusek knew he needed as much help as he could get. A few miles from Washington, D.C. is one of the largest complexes of its kind in the world, the laboratories of the National Institutes of Health at Bethesda. They had the facilities and experience which might make all the difference. The director offered assistance, and Gadusek knew precisely what he wanted the laboratories to do first.
It was to be a process of elimination to discover if Kuru were caused by something in the environment, perhaps even something in the food they were eating. As fast as the scientists eliminated suspects, others were collected in Papua and sent for examination. Seeds, grains, berries, leaves, grasses, bark from the trees, anything growing in the Eastern Highlands that might pose a threat to human life was analyzed in the search for the cause of Kuru. They cultured colonies of suspicious bacteria and viruses, but nothing that grew seemed to fit the bill. Drinking water was analyzed for harmful trace elements. There weren't any. Samples taken from the bodies of Kuru victims were injected into living creatures to see if they developed the symptoms of Kuru. Nothing happened. One after another, lines of inquiry were ruled out. and at last it seemed that the land itself was safe. Kuru could not be traced to anything specific in the environment. They were now wondering if Kuru could be a genetic disease, which was being passed on through families in their genes. Whatever it was, they knew it affected the central nervous system, and the next logical step in the investigation was obvious. Carlton Gajusek didn't relish what it would involve. The first brain from a Kuru victim to arrive in Washington came from a middle-aged woman. It wasn't in very good condition, and they needed others. Soon they were arriving in batches. The human brains had made the journey from the eastern highlands of Papua, wrapped in muslin soaked in formalin. Each brain was prepared in exactly the same way, so that it could be sectioned and stained for examination under the microscope. Igor Klatso, the neuropathologist, was asked to examine the microscope slides of the Kuru brains. He didn't really want to, because he felt there were more important things to be getting on with, but he got down to work. On the face of it, there was nothing abnormal. But when he looked closer, he could see that there was something wrong. He saw these, spider webs of multiplying brain cells, which he recognized as astrocytes. They're not uncommon, but in the Kuru brain there were far too many of them for comfort. Then he saw these. There were gaping white holes where nerve cells should have been. But here was the most puzzling thing of all. Extraordinary plaques standing out from the rest of the brain, marking trails through the tissue like strange footprints in new snow.
And as he stared, Klatzer remembered seeing plaques like those when he was a student in Germany. He took many photographs of the Kuru brains under the microscope. Sometime later, in the way that these things happen, they found their way to a medical exhibition at the Wellcome Institute in London. A selection of Gajusek's own photographs of Kuru patients were also on view. Among the visitors to the exhibition was a vet from the United States who was in Britain studying disease in sheep. The photographs which particularly interested him came from Klatzo's collection of microscope slides. There were the pictures of the holes in the Kuru brains, and others showing the spidery astrocytes. The scale of the damage was colossal. And then there were the mysterious Kuru plaques. The vet was fascinated.
There's a disease called scrapie, which attacks and kills sheep and goats. Farmers have known for years that scrapie is infectious, and when animals catch it, they are usually slaughtered quickly to stop it spreading through the flock. In some parts, the carcasses end up in butchers' shops. No one has ever discovered exactly how scrapie spreads, but hundreds of thousands of animals still perish from it. The classic symptoms include uncontrollable trembling, and in some unfortunate beasts, the torture of continual itching. The American vet who'd seen Kuru at the London exhibition was a specialist in scrapie. Bill Hadlow had spent many years trying to understand it. The disease was unusual because it could take up to 4 years to incubate. And though they were infected, animals looked perfectly healthy until the first symptoms appeared. Hadlow believed that the virus responsible was probably unlike any other in medical or veterinary science. He knew what the brains of infected sheep looked like, and from what he had seen, the Kuru brains bore striking similarities.
I indicated what I had observed in terms of the parallelism between the two diseases, and in view of what we knew about the transmissibility of scrapie, I had suggested that it might be wise to make an effort to see whether Kuru is transmissible under similar circumstances, in this case by inoculating some laboratory primates. And my main concern was to make this suggestion known to others who might be in a position to do this.
He wrote to The Lancet, the British magazine for doctors, and his letter was read at the National and eventually by Carlton Gajuzek himself. What Hadlow was suggesting was that Kuru in humans might be a slow-developing infection like scrapie in sheep, and the similarity did not end there. Both diseases shared the same symptoms of trembling and loss of muscular coordination. But perhaps the most startling suggestion was that, given enough incubation time, Kuru might turn out to be a transmissible infectious disease after all. Hadlow's letter to The Lancet offered a brand new lead, and they grasped it in their hunt for the cause of Kuru. 25 miles from Bethesda in a secluded park, preparations began for the new experiment. In all, 54 chimpanzees would be used before it was over. If Kuru were an infection caused by a slow-acting organism, these animals would certainly live long enough to show it.
So, we'll go through that. Okay, well, this is the building. This is where the chimpanzees, the monkeys were kept. This is where a multi-million-dollar program...
Joe Gibbs, a research virologist, was selected to take charge of the entire experiment.
We were faced with the remarkable situation that had not been done before in the history of human medicine. And that was to take human brain material and put it into the brain of an animal, chimpanzees primarily, and hold them for 5 years. And I can tell you, it was a difficult job.
Meanwhile, in the Eastern Highlands, they were investigating the question that had been worrying them for many months. Was Kuru being passed from generation to generation in the genes of the Foray people? Was it an inherited disease? 2 anthropologists were sent to the Eastern Highlands from Adelaide University to find out.
Bob, didn't Yanayu have an older brother who migrated out to Kainantu?
See, Yanayu, yes, he went first to Hanganofi, and he stayed there for 6 months, and then he went into...
Robert Glass and his wife Shirley were there to discover how long the disease had been in the tribe. Their job was to collect the evidence that would show if it could be traced through family lines. They learned the language and studied foray tribal life in detail, particularly the rituals of marriage, birth, and death. The days were spent questioning the members of the tribe, then double-checking the answers. The nights were spent writing up their findings, and soon they confirmed what Carlton Gajazek had already observed. The women and children of the tribe were more vulnerable to Kuru than the adult men. Much of their work involved drawing up family trees, stretching back as many generations as the foray people could remember. It was the surest way to confirm one way or another if Kuru was inherited. The K was for a Kuru victim. But as their evidence grew, they realized that the genetic theory wasn't standing up. The disease hadn't been around for long enough, and it seemed to always bypass the men of the tribe.
A neurologist from New Zealand asked us a very good epidemiological question. He said, what is it that the foray adult women and children of both sexes do that the adult men don't do?
The anthropologists had already observed that the adult men led largely separate lives from the women and children. The men were hunters, and the meat they killed they usually kept for themselves. It was women's work to look after the pigs, but unlike the men, the women rarely ate them. Women and children ate vegetables mostly, and small rodents when they could get them. And as the anthropologists continued their investigation, they remembered that one of the traditional roles of the women was to prepare the bodies of the dead for burial. They continued probing and questioning until the women told them that, frankly, it was normal practice for them to cook and then eat certain parts of the corpses, including the brains of those who had died of Kuru.
Cannibalism is not something very extraordinary in New Guinea. It occurs in quite a few places, and it's basically a cannibalism that's related to kinship. You consume the bodies of the dead of certain of your kin.
They also discovered that sometime around the beginning of this century, ritual cannibalism had given way to a more frequent consumption of human flesh. Rarely were the adult men involved. The women and the children who were always with them were in close contact with the Kuru dead as they prepared them for burial. That might offer another explanation if Kuru were an infection. It looked as if they had isolated a reason for the outbreak, but the question still remained: what was causing the disease? The chimpanzees had been living contentedly for 2 years in the Maryland countryside when one morning an animal showed signs that something was wrong.
I was told that there had been some changes take place in one of the chimps and I should get out here right away. The animal had the shivering tremors that was so typical of the Kuru foray natives in New Guinea. They had a blank expression, and it was unbelievable that we were seeing a reproduction of the human disease. In fact, it was so unbelievable that I didn't believe it.
But it was true, and soon it was dead.
We brought the animal up here and prepared the animal the same as you would do for a human autopsy or a surgical procedure. And we flew one of our closest collaborators in from England, Elizabeth Beck, who was a neuropathologist. And so we were all gowned and masked and gloved, and the sterile field was preserved entirely as you see it in an operating room in a hospital. And we proceeded then to extract the brain from the animal and to gently remove it so that we wouldn't distort the tissue. Elizabeth gingerly carried the brain back to England and gave us a quick report by telephone that this was the most rampant pathological lesion, so consistent of Kuru that she'd ever seen. You'd think the story would stop there, but it didn't. That was only the beginning, because suddenly we had another chimp, and Daisy came down, and then George came down, and then Herman came down. Carlton was calling from Australia saying, send a brain here, send a brain there. I was beginning to worry that we were going to run out of brain tissue, but we didn't, thank God.
Slices of chimpanzee brain were made ready and sent for examination to eminent neuropathologists all over the world. The carefully prepared transparent slivers would be studied for signs of Kuru. If they were found, they would have confirmed at last that Kuru was caused by a transmissible infectious agent. And there they were, scattered through all the animal brains, the unmistakable picture, the spider webs of multiplying brain cells. The holes where nerve cells had once been. There could no longer be a shred of doubt. The chimpanzees in the United States had the same disease that had killed thousands in Papua New Guinea. Seven years before, it had been Igor Klatso, the neuropathologist at Bethesda, who had been the first to see Kuru plaques in a human brain from Papua. He remembered that something similar had been observed many years before in another rare and fatal condition. He had looked it up again in one of the textbooks from his student days in Germany. He hadn't been mistaken. It was called Creutzfeldt-Jakob's disease, CJD for short. There was no doubt about the similarities. As far as he could tell, the brain damage in Kuru was identical to the abnormalities found in CJD cases. And so were the plaques.
It was a bombshell. Was it possible that Kuru wasn't a unique one-off disease, but there was another like it, much closer to home? They needed a CJD brain to find out.
We immediately set out to get one, and we got that from Beck in England. We inoculated a chimpanzee, and in less than a year, the chimpanzee was down with a neurological disease with all of the clinical manifestations or the clinical signs of human Creutzfeldt-Jakob disease. Well, this, of course, electrified Western medicine, because now we were not dealing with a remote disease in a remote population that most physicians in the world would never see. Now we're dealing with real-life situation. We're dealing with a disease that, while it was rare, people had seen in Western medicine and had described in Western medicine.
The scientists at Bethesda had succeeded in transmitting another human brain disease to animals. And now there was evidence that the infectious agent responsible was the same kind of slow virus they had found in Kuru patients in the Foray tribe. It had to be one of the most significant medical findings of the century, the discovery of slow viruses in Papua New Guinea by Carlton Gadusek.
On behalf of the Karolinska Institute, I would like to convey to you our warmest congratulations. And I now ask you to receive your Nobel Prizes from the hands of His Majesty the King.
Carlton Gadusek had discovered the potential cause of Kuru, but the story was only just beginning, and no one knew where it would lead.
The applause had barely faded in Stockholm, and doctors everywhere were looking again with renewed interest at other baffling degenerative brain diseases with the hallmarks of Kuru. It was all unknown territory.
Morning, darling.
Morning, darling.
Janet is 49 years old, a mother of 3 grown children, and she lives in Britain. She has a rare and fatal brain disease of a kind the doctors call dementia. Her dementia is familial. It's called Gerstmann-Straussler syndrome, GSS, and it runs in families. It has always been known to be an inherited disease. But where Kuru attacks the centers of the brain which control muscular coordination, GSS attacks and destroys the parts of the brain responsible for intellect.
You know what day it is tomorrow?
Sunday.
No, it isn't. Yeah, but it's Simon's birthday. That's right.
Simon's birthday.
Yeah. You know how old he is?
I don't know.
3 years old.
3 years old, yeah.
3 years old, so we'd have to make sure we get him a card game, won't we?
Mm.
Right?
Yes.
Drink up then.
When the symptoms appeared, Janet's husband knew her life was coming to an end. After 30 years of marriage, he's now become nurse and housekeeper. For him, every day's the same.
A quick tidy round and virtually down to do some shopping. Supermarkets, or mainly a supermarket, because we found it much easier to walk around with a trolley and to pick out what we want rather than go from shop to shop. Because she gets a little bit unsteady on her feet at times. What one do we have, Norman? That one or that one? This one or that one? That one.
The family tree tells the tragic story.
This family tree goes back to 1853 here, and then we come on to a grandmother's line along here.
The black spots indicate deaths from GSS.
And onto a mother's line, which is this one here, to my wife's and our children's line along here, and then our grandchildren line, which is along this line here.
And the horror for him is that they now predict that half their children and grandchildren will die from GSS by the time they reach their 50s.
Isolated case completely. But the rest, the majority of them are dying in a range from 46 to, say, 62 at the very most.
It was Carlton Gajusek's work on Kuru that led the British doctors to look again at GSS, the inherited disease. Samples of brain from Janet's relatives who died in recent years with GSS have been kept frozen here for medical research. 2 years ago, her second cousin died. Her brain tissue is in this capsule. Though they knew that GSS was inherited, they wanted to see if the lethal gene could be transmitted like the other slow viral infections. It was a long shot, but in the light of Kuru, it was important to check. It would involve another series of animal experiments similar to those that had taken place near Bethesda. The marmoset monkey is anesthetized. It will feel no pain.
No one in their right mind would do this to any living creature without a great deal of thought and a very good reason. And they had a very good reason. Millions of human lives will benefit from research like this. It's all over very quickly, and the marmoset is returned to its cage with the extract of human brain inside its skull. The experiment involved 8 monkeys, and they all lived normally for 18 months before the unmistakable symptoms of GSS appeared, and they died. It was incredible. A genetically inherited disease had been clearly shown to be transmissible like the other slow infections. And when they examined the marmoset brains, there was no doubt that they'd died with GSS, Janet's disease. The hallmark of Janet's inherited condition, the same Kuru-like brain damage.
Now they knew that GSS involved more than an inherited lethal gene. But what was it? There was no immediate explanation. Once again, Kuru was leading scientists into areas that cast doubts on the conventional wisdom of disease and infection.
So, now along with Kuru, there were 2 more fatal slow infections, CJD and GSS, Janet's disease. No one would handle infected brains as casually as this ever again. Gadusek was already warning of the dangers, and he had good reason.
If these diseases of the brain could be transmitted in the laboratory, they might be transmitted elsewhere, especially in surgery. By the late 70s, there were disturbing reports in the medical press. The problem was that standard sterilization techniques were clearly not good enough to deal with slow infections, and they realized that there was a risk of cross-infection from the demented to the healthy. And the warnings were not coming a moment too soon. There is a difference between suspicion and hard proof, but proof came, and tragically. It was a routine corneal transplant in the United States. 26 months after the successful operation to restore sight, the patient developed CJD and died. The cornea had come from a donor with the same slow infection. It shouldn't ever happen again. These days, the brains of donors are always examined for signs of slow infections. But the accident was the spur to more research into the natural history of slow infections and the plaques which accompany them. What were they? They knew that they were made of a protein called amyloid. So were the plaques of scrapie, which by that time was no longer confined to sheep. In many research laboratories, they had successfully taken scrapie from sheep and transmitted it to small and convenient laboratory animals. And here in Staten Island, New York, they were studying the natural history of the plaques in all their stages of development. They were attempting to answer some basic questions. Were the plaques, in fact, clumps of slow viruses, or were they merely symptoms of the damage the viruses had caused? Pat Mertz, an electron microscopist, was given the job of searching for slow viruses in the brains of laboratory animals infected with scrapie, when she stumbled on something she'd never seen before. It reminded her of the kind of viruses which attack plant life. She took this picture of it. It was the shape of it that intrigued her, long and fibrillar, unlike any human or animal virus ever discovered. But was this a slow virus?
How is it coming out, George?
Pretty good.
Up to the scrapies.
You about ready?
About ready.
It was painstaking work, and she spent a year searching under the electron microscope and building a photographic dossier on the fibrils. She found them in all the known slow infections in humans, Kuru, CJD, and GSS, as well as in scrapie in animals. They were there wherever slow infections had struck. She began to wonder if she was looking at the cause of the diseases. But it was too soon to say, even though she had the advantage over Carlton Gajazek, who, 20 years before, had struggled to discover the cause of Kuru without the technology that was now available to her.
In all infectious diseases, you try to isolate a structure and that is associated specifically with infection and infectivity and high titer. Then take that apart biochemically to determine its constituent pieces, and then understand how that structure, when put back together, will cause the disease in the host. And that's the aim of all infectious research, to understand and to treat the disease in the human. Gajazek attempted to do this, but the techniques were not developed at that time for him to do it.
At the Staten Island laboratories, they had developed techniques to distill the essence of the scrapie slow infection from the diseased brains of laboratory animals. The stages in the process to isolate the infectious particle. The brain solution is spun at high speed in a centrifuge. The process is repeated many times over a number of days. The object? To separate this brown blob of infectious material from unwanted brain tissue. After washing in detergent, it's spun in the centrifuge once again. And this is what they end up with, a tube full of concentrated infection. This is what Pat Mertz examines with infinite care under the electron microscope. It's extremely dangerous stuff. It kills laboratory animals, and the symptoms they develop are those of the slow infection it contains, in this case, scrapie. A single drop contains millions of fibrils. Even now, they still lack the final proof. So they remain professionally uncertain that this is the slow virus they've been searching for, the cause of Kuru and other dementias in humans. But the fibrils and the plaques seem to go hand in hand too often for mere coincidence.
The human Kuru plaques, similar to the CJD plaques, similar to the GSS plaques, all apparently similar to the plaques of scrapie in sheep.
Well, all of this then is starting to pull a concept together that's going to have, I think, a confirmatory role to play in what Gadushek said in the first year of the discovery of Kuru, namely that if I understand what causes Kuru and I understand the mechanism of the disease, it will have far-reaching applications in my understanding and in Western medicine's understanding of other so-called degenerative brain diseases, particularly those that fall into the category of senile dementias.
Senile dementias, the scourge of aging populations in the developed world. Once again, Gadushek was right. Now we know that the older you get, no matter who you are, the more plaques there'll be in the brain. And to the eye, their similarity to the plaques of Kuru is striking. And the more there are, the greater the loss of memory and intellect, and the greater the destruction of the personality. Alzheimer disease is the most common dementia of them all. It strikes at 1 out of every 4 families in the West, and its victims have plaques in their brains.
Jim Luby is 53, and he's got Alzheimer's disease. His family cares for him as if he were a child.
You gonna keep now, or should I come pick you up?
There are millions of sufferers in the world today, and millions more will develop Alzheimer's before they die. It's the 4th biggest killer in the United States, and as people live longer, the problem inevitably grows worse.
I need to do some things tomorrow. I could go shopping. Yeah.
It's not hard to recognize the symptoms.
I need to.
He had a lot of responsibilities with his job, and he started to lose his ability to compute math. His boss was the first to notice it. We didn't find out until much later.
Hey, Dad.
Okay.
Put in your mouth. Okay?
Mm-hmm. Yeah.
Don't chew. Don't chew.
No,
No, swallow. In your mouth. No, swallow.
It's so different to watch him. It's sometimes really hard to remember what he was like before. He's 2 different people to me. My dad's gone. It's my father, but my daddy's gone.
You go with Mom?
Yeah.
To the store?
Not yet.
You're going to go for a walk?
Yeah, for a walk.
For a walk with Mom?
Yeah,
Okay.
Yeah, that's where we're going. Okay, let's get down there before we.
The question is, are the plaques in the brains of Alzheimer's patients associated with slow viruses? In other words, could some forms of Alzheimer's be caused by slow infection, rather than the natural process of aging? Nobody knows, but they're trying to find out. Heinrich Wisniewski heads the Staten Island team that first found the fibrils in slow infectious diseases. Now their effort is focused on Alzheimer disease and the plaques they find in the brains of victims when they die. They're trying to find out if Alzheimer's is yet another slow infection.
In all unconventional viral infections of the type which we see in humans, in Kuru and Creutzfeldt-Jakob disease, we see also the amyloid and neuritic plaques, because we see them also in Alzheimer's disease. We are now exploring the possibility whether they are also being triggered by the same type of unconventional virus which we see operating in Creutzfeldt-Jakob disease, Kuru and scrapie.
Only a few generations ago, there were few cities without an asylum workhouse for the disadvantaged. Today, there isn't a city anywhere in the West without its new homes for its ever-aging inhabitants. That's where you see the tragic results of Alzheimer disease. One can't help wondering if, in a sense, this isn't the Kuru of the Western world, and scientists are now searching for its cause, as Carlton Gajdusek searched for the cause of Kuru.
We now design experiments which are aiming at transmission of the Alzheimer disease into experimental animals. We design a protocol very similar to that, which people prove the presence of infectious agent in Kuru and Creutzfeldt-Jakob disease.
When I was a girl, we all thought that as we grew older, we would naturally become more absent-minded and dotty simply because we were getting old. These days, doctors know it's not that simple. They suspect that some dementias could be infections that develop only if you live long enough, which in the West we mostly do. So, as Carlton Gajdusek did 30 years ago in Papua New Guinea, they search for the cause, because until they've found it, they're unlikely to discover a cure. It's strange to think that the whole story began here, so far from the civilization we inhabit. Stranger still to think that the search for the cause of Kuru has led so remorselessly to the diseases which have begun to devastate us. There's more truth in the old saying than we think. We're all much the same under the skin.
Heart disease can be prevented. Find out how with Jim Lehrer on My Heart, Your Heart, coming up next on TV 34.